Okay, so today what we're doing is we are starting with, we're basically continuing with research methods, but we're just looking at, we're just moving on to looking at the sampling procedures now. So basically, the first thing that we should do is we should define what is sampling, okay? So sampling is obviously related to the word sample, and sample means the participants in a study. So sampling is the process or the technique that you use to get those participants into your study. And so sampling is basically defined as the process of selecting participants for a research study. And there are different ways in which we can select or sample participants for a research study. The first one, which you would have remembered learning about last year, is random sampling. Random sampling is a really good sampling procedure because it actually helps you to basically ensure that every member of the population has an equal chance of being selected for that particular sample. Okay, so basically what random sampling is we take all the names of the people that are supposed to be in that study, and we basically try to ensure that they each have an equal chance of being selected. So it's not that person one has more of a chance of being in the study than the other person. Everyone has an equal chance there. And because everyone has an equal chance, we end up getting a sample that is representative of the population. Okay, so basically with the random sampling, or what random sampling really looks like, is you might get a bunch of participants' names and you put that in a little box, or you put that in through a computer. And then that computer might generate a random list, or you draw the names out one by one from the box and you're getting a random kind of selection there. Okay, random sampling is good because it allows us to generalize results. Okay, no other sampling technique allows us to be able to generalize results back to the population. It's only random sampling that allows us to do that. And so a lot of the time, random sampling is good in that sense. There's an advantage there because we can generalize results, but the disadvantage is that because random sampling is by its nature random, there's a lot of individual participant differences that can actually come up. And remember, we already learned about this last time in our last session, that individual participant differences can become a potential confounding variable for your study. So it's always something we want to be kind of wary about and kind of cautious about. So that's random sampling. Remember, random sampling is a really good sampling technique. The only sampling technique we can use other than random stratified sampling, which actually, produces a representative sample, thereby from which we can generalize results back to a population.
Miss,
Yeah.
how can we tell that they use random sampling in an experiment, other than picking out names from a hat or something like that?
Oh yeah. So yeah, picking up names from a box, or generating a random list using a computer program, or for example, putting all the students' names into like a lottery kind of thing, and then just picking them out one by one. So anything that suggests that everyone had an equal chance of being selected, and that, the researcher didn't just say, okay, you be in my study, you be in my study, and choose. Okay?
Yeah, thank you.
No worries. Okay, so the next type of sampling technique that we look at is called stratified sampling. So stratified sampling is basically dividing your population into strata. So strata, if you remember from humanities classes, it refers to layers, okay? When you learn about strata are like layers of the earth. So strata, in other words, are layers. So you take your population and you divide them into different layers or different groups, and then you choose participants from within those groups. So the most simplest example you can take is that if you're doing a study on high school students and you want to assess, you want to assess like academic performance in, across the years of high school. And you want to basically take students from year 7, 8 up to year 12. Now, what you do is the best kind of method to use, or the best sampling technique to use for this particular kind of study would be stratified sampling. So with stratified sampling, what we're really doing is we are, dividing the population into layers or groups and picking people out of the population. So I take, all the high school students at Altaqua, take a bunch of people in year 7, take a bunch of people in year 8, year 9, 10, 11, 12, and then I choose a few students from each of that strata according to my research needs. So if I've got 20 students in my year 7 strata or my year 7 layer, I then ask their English teachers, okay, give me your best spellers, the people who are really good with English, or with, give me your highest scorers in English. And I take those specific students, maybe 5 or 6 students out of those 20 that were in year 7, out of that group, because maybe my research topic is literacy skills or English skills across the years of high school and how that develops. And then I go to year 8. I go to the year 8 layer. I've got 25 students in the year 8 layer. That's okay. Then I ask their English teachers, okay, who are the best English students in year 8? And I take maybe 5 or 6 out of that. And I continue that process up until I get up to year 12. So what I'm essentially doing here is that those students, those 5 or 6 students, which I then picked from each of those strata, from each of those year level groups, have now become my sample. So I might end up having about 35 people in my study, maybe 5 or 6 people from each year level there. Okay, so generally, that's what stratified sampling is: taking a population, dividing that population into different groups or different strata or layers, and then basically choosing a few participants from each of those layers. Now, the last stop point here that says generally we select participants in the same proportions as they exist in the population sounds a bit confusing, but all it really means is that you know that if we look at the number of year 12s at our school compared to the number of year 7s, we've got like millions of year 7s. They're just running around everywhere. Whereas with the year 12s, we've got a slightly lesser number, okay? So if you've got about 100 students in year 12 and about 160 in year 7, because year 7 students are, the total number is so high to begin with, we will end up picking more year 7 students for our sample, because we have to select participants in the same proportions as they exist in the population. If we've got a bigger year 7 total number of students to begin with, we are going to end up choosing more of them compared to year 12s. Okay, it's just basically from a numerical point of view. So that's what stratified sampling is. Does this kind of make sense? Because I know this one can be a little bit confusing.
Yes.
Yeah.
Can you tell us the disadvantage for this?
Yes, a disadvantage for this is that it can be quite time consuming. And on top of that, sometimes when you're using stratified sampling without the random part in it, without randomizing, there can be some bias that comes into it as well. Yeah. So you might be picking participants, but then those participants are not representative of the population, because you're not picking them randomly. You're just picking them based on who's the best English student in that year level. So not everyone has an equal chance of being selected. Okay, it's kind of like same disadvantage that you use for convenient sampling, saying that you can't generalize results, you can use for stratified sampling too.
But you can generalize from using this, right?
You can't generalize from using this.
You can't?
Random. Yeah. There's another one we're going to talk about called random stratified sampling. That one you can actually generalize results, but this is just plain stratified sampling, so you can't you can't generalize from the.
Right.
Yeah.
And
okay,
that is to reduce the bias thing, yeah?
Yeah, exactly. Okay, so the next one, this is the one now. Random stratified sampling is exactly the same as stratified sampling. Only one main difference though. The one main difference is that when we are selecting students from year 7, year 8, year 9, year 10 from those different layers, we're not choosing them based on a characteristic. We're not asking the English teachers, give me your best English students. We're not choosing who's the best at maths from each year level. What we are doing is we are randomly selecting. So we take those 20 students in the year 7 strata, and then we put all those 20 names in a box, and we pick out the first 6. And whichever first 6 we pick up, those automatically become our year 7 participants for our sample. And same for year 8, same for year 9, up to year 12. Now, that's the reason why the only 2 sampling techniques we can use that allow us to generalize results are random sampling and random stratified sampling. Okay, because normal stratified sampling that we looked at on the previous slide and convenient sampling don't allow us to generalize results, because we haven't made an attempt to randomize the sampling or to ensure that everyone has an equal chance of being selected. So that's why random stratified sampling allows us to generalize results, because it's kind of like stratified sampling plus random sampling combined into one technique. Okay, so that's basically what random stratified sampling is. Just the same as the previous slide, but you're just randomly selecting them from each of those strata. Okay, so if we're all good with that, we can move on to the last sampling technique and the one that we're all probably most familiar with, which is convenience sampling. Okay, now just remember with the terminology, it's convenience with an E-N-C-E at the end, not convenient. Okay, Vika have been quite strict about this. It's an easy mistake to make, honestly, but they're quite strict with this because it is a key terminology. If you write convenient sampling, E-N-T, in an exam, they will give you 0 marks, even though they know what you are trying to write, or they know what you are trying to basically demonstrate in that question. They will still give you 0 marks for use of wrong terminology. So just be really careful. You know, this always happens every year, no matter what year level, no matter what cohort. So just be careful, and remember it's convenience, not convenient. Okay, convenience sampling is basically a sampling technique that we use where we're just picking participants as a researcher. The researcher is just picking participants according to how easily accessible those participants are or how close they are to the researcher. So if I'm working at a university or I'm working at a school, it's going to be easiest for me to use you guys as the participants of a study I might want to do, because you guys are easy for me to access. I see you guys most days, so it's easy for me to kind of be able to use you guys in my study, as compared to going outside and finding a bunch of you know, other VCE students. So obviously, convenient sampling is good, or the advantage of convenient sampling is that it's super easy for the researcher. It's very, very quick. It's very quick for the researcher to find participants. So if a researcher is studying children, they might want to talk to a few of their family friends or a few of their relatives and be like, can I use your daughter or son for my research study? Can they participate? Okay, that's what convenient sampling is. Problems with convenient sampling, though, are number one, because a lot of the time the researcher might know the participants who they're conveniently sampling, there's some bias and some expectations that can come into place. Number two, even if you don't know the participants, even if you've just put up a newsletter or put up an ad in a book or in an online website saying, okay, volunteers wanted, blah, blah, blah. The problem with having convenient sampling is that you can't generalize results. Why? Because a convenient sample is never a representative sample. What that means is the people who are in the convenient sample have not been randomly selected. They haven't been in a situation where everyone had an equal chance of being selected. It was just first come, first serve, okay? A lot of the time, one easy tip for you to pick out convenient sampling in any scenario is to look for the word volunteered. If it says 27 participants volunteered or 27 university students volunteered, volunteered suggests that there was an element of convenient sampling that was used there. Okay, so just remember the advantage of convenient sampling is that it's quick, it's easy, it's time effective, it's cost effective, but the disadvantage is that you never get a representative sample from a convenience one, and that we cannot generalize results because of that. Okay, so that's basically what convenient sampling is about, and most of you are quite familiar with this anyway. Okay, so moving on now to allocation. Now, when we talk about allocation is basically different from sampling, because sampling is us actually selecting participants to be in our study. Allocation happens after sampling, okay? After we've chosen the participants to be in our study, we now have to allocate them. We now have to divide them into groups. We have to choose, okay, which participants are going to be in my experimental group, which participants are going to be in my control group, okay? Because that's what allocation is. Allocation is when you divide something out, okay? That's what allocation means. So random allocation, similar to the concept of random sampling, whenever we talk about something random, it means that everyone has an equal chance of being selected, yeah? When we talk about it in the context of allocation, random allocation means that every person that was selected for that research study or experiment now has an equal chance of either being put into the experimental group or the control group. And the researcher cannot do that in a biased way. They can't say, actually, you know what, you're a really good speller, you come into my experimental group. No, they can't do that. They have to take all the 20 names of the participants or 27 names of the participants in the study And then the first maybe 8 that they draw out, they automatically be in the experimental group. The next 8 that they draw out, or the next 10 that they draw out, will be in the control group. Okay, so basically everyone has an equal chance of being selected. Random allocation is really important. It's not so important as for like generalizing results, but it's more important for ensuring the general reliability of the results and making sure that there's no bias in terms of how the participants were allocated, because we know if there was bias, it could go on to reduce that reliability of the results that are obtained. So remember, allocation always happens after sampling, not before, always after. Now we look at the research designs, and I know that there are a lot of issues with these research designs here. Last year's group used to always get confused with this. I'm pretty sure you guys will get confused with this as well, because generally the research designs can be a little bit confusing, can be a little bit difficult to identify in research kind of scenarios and case studies. We will try to go through a few examples. As long as you know what the differentiating factors are between the three, I think you should be okay, to be honest. So remember, you need to know the terminology. If you're ever asked to identify a research design in a SAC, you are only going to be writing either of these three terms there. Okay, last year I remember when we gave a question like identify the research designs, some students mentioned convenient sampling or case study or like other stuff, like random things that were not even under the topic of research designs. So this is why it's really important for you to look through your study design and to look at the headings that I put on these slides or that we put in the notes, okay? Because these headings and certain things that we put in bold or underline are key words there. And these are the words that VCAR will use if they are expecting you to show knowledge of this topic, okay? So a research design is basically a way in which the study is set up, okay? So we've got our participants, we've allocated them to experimental and control group. Now we want to set up the study, okay? Now we want to basically set out, okay, which participant is, you know, how is the study going to run? Are we going to run this by experimental and control group? Are we going to make one participant go through both conditions? Are we going to match participants? Okay, so basically the research design sets up the general structure of the study, okay? These are some general definitions. They're just taken from the book, just for a quick overview, but we will go through these in depth in the next few slides. So in basic terms, independent groups means each group is independent of one another. A clear separate experimental group, a clear separate control group, where every participant is different. Repeated measures is where you've got one participant, any one participant in that study will be involved in both the experimental condition and the control condition. So you can imagine that there'd be less general, like a total number of participants in this, because we're making use of each individual participant for both conditions. Matched participants is when we match participants based on a variable. So if we're looking at driving ability, we look for, you know, person A has driven for 25 years. We look for another person in our sample or population who has also driven for 25 years. So then driving ability doesn't give anyone an unfair advantage or disadvantage in that study. Okay, we'll go through these in a little bit more depth now. So before I go through each of them and just kind of show you the differentiating factors, we have to remember that it's important for us, and it is a VCAR key knowledge skill, for you to be able to evaluate the different research designs. Evaluate means you need to be able to state the advantages or the plus points and the negatives, which are basically your disadvantages for each of those research designs. Okay. So the first one is independent groups. So like I said, independent groups allocates participants randomly so that they are either in the experimental group or the control group. And random allocation is most used with the independent groups design because it reduces those participant variables. So obviously, as we learned about early on, the experimental group is the group exposed to the IV, and the control group is the group that's not exposed to the IV. They're the group that are used as a baseline for comparison, comparing the results. So when we look at independent groups design, you can see that if we look at these diagrams here, A, B, C, D, E, participants A, B, C, D, E are completely different from participants F, G, H, I, J. Okay, they're not the same. Basically, they are completely different participants. Same thing in this diagram below. You can see that they're all different participants, that they're all different, kind of like in different color. So that's, and there's a not equal sign there. So that means the people in the experimental group are not the same as the people in the control group. They're completely different people. This is good because it means that each individual person will enjoy their time in the experiment. They won't get bored, they won't get tired, they won't get annoyed that they have to be doing 2 conditions at the same time. And so the chances of participants dropping down is quite low. Another really good thing that really brings up independent groups design and is an advantage is that independent groups design is a super straightforward, super easy, cost-effective, time-effective design to actually set up, okay, from a practical point of view. So it can be completed quickly and without too much costs or time getting wasted. The disadvantage, though, as you might imagine, is because we're using, let's say, 8 different people here, and each of them is a completely different person from the other person. We are opening up, you know, a lot of individual participant differences there, which actually can act as a potential confounding variable. So basically, we have to remember that in certain independent groups design-based studies, individual participant differences can very likely become a potential confounding variable, which goes on to confound the results. Now, independent groups design also has another name. We don't refer to it a lot in VCE, but if you come across this in EdRoller or in some online resource, you should know that another word for independent groups design is between subjects design, okay? You don't need to know that for the SAC. We're never going to use that in a SAC situation, but just for your own knowledge there. Okay, so that's basically our independent groups design. And it's the most commonly used design. In most case studies in research methods, they will have used independent groups design. Not all, but in most. Okay, as long as there's a clear experimental and control group and there's no indication of a participant being used more than once or going through a repeated trial, then that would most likely be an independent groups design. Okay, the next design we look at is called a repeated measures design. So repeated measures design is when you've got the same participant going through both the experimental condition and the control condition. And so that essentially means that that same person, or in this example, person A, person B, C, D, E, they are a participant in both the experimental group and both the control group. So essentially in one trial or over 1 week, they might be exposed to the IV. The next week, they are not exposed to the IV. Now, the good thing about this is obviously it does reduce individual participant differences. It's the same person going through the experimental condition and the control condition. So because it's the same person being reused, essentially, there's going to be less individual participant variation or differences there. And so the IV is the DV or the results are going to be less likely to be confounded by other variables other than the IV. Now, obviously, we learned about the disadvantage of this. The disadvantage of a repeated measures design is a confounding variable in and of itself, and it's called the order effect. Order effect means when this guy is repeatedly going through the experimental condition, then the control condition, then the experimental condition and the control condition, in that same order, maybe week after week or day after day, he is going to get super bored, he's going to get super tired, and he might want to drop out of the study. Or on the flip side, he might get really good at the tasks he's doing and start to improve in terms of his performance, which is not a good thing because that's what we call a practice effect. The practice effect makes it difficult for us to determine whether it was the improved practice or whether it was the IV that caused the change in the results. Okay, so we obviously said that one thing that we can do to minimize the effect of order effects or minimize our control order effects is use counterbalancing. So counterbalancing essentially means that person A goes through the experimental condition and then control condition 1 week, but then the next week starts from the control, then goes back to the experimental. So it's kind of like they're mixing up the order a little bit there rather than just sticking to the same order of tasks every time. Okay, so that's what the repeated measures design looks like. In case studies or scenarios, usually you would know it's a repeated measures design. If it says something like the same participants were used, the same participants had to do this, and then they had to, the same participants had to, for example, be sleep deprived, and then the next week, the same participants followed a normal routine or sleep pattern. So if there's an indication there, or if you cannot clearly pinpoint a separate independent kind of experimental group and a separate independent control group, and they kind of look like they're merging into one, or the same person is going through both conditions, that is going to be an example of repeated measures design. Okay. And obviously, if you are asked in a question like that, what is the kind of like, you know, potential confounding variable, that would then be order effects. So you can talk about that. Okay, the last design we go through is a little bit more straightforward. It's called the matched participants design. So matched participants design doesn't mean that you're looking for a person's identical twin. It basically means that you're looking for a participant. So if I've got participant A here, this participant A will go through the experimental condition, but they don't go through the control condition. So what the researcher has to do, the researcher has to find someone who is so similar to this person in the population, and that person becomes their match, okay? They're not the same person, because you can see that this one's purple, this one's pink, but essentially this person is so similar to this person, to the person in the experimental condition, that they become what we call a match. So person A goes through the experimental condition and person A's match goes through the control condition. Essentially, this is kind of similar to repeated measures, but it's not the same person going through both conditions, okay? But it's similar to repeated measures in the sense that the advantage of a matched participants design is that they will tend to be lower individual differences because the participants are matched to be as similar as possible, okay? Even though it's not the same person, they are matched to be as similar as possible in terms of those characteristics. The disadvantage, though, is that you can imagine trying to find a match for a particular person in the population. It's not easy work. It's time consuming. It's costly. You've got to incur a lot of costs and spend a lot of money to be able to find the matching pair, because you'll be recruiting them through different organizations or systems. And the biggest problem with matched participants design, which we don't see in any of the other designs, is that let's say that this is person A. Person A is nicely doing the experimental condition. They're doing all the tasks that are required of them. Person A's match one day decides, you know what, I can't be bothered doing this study anymore. I'm out. And they decide to withdraw or get out of the study. If they get out of the study, person A's results automatically become invalid. They're not valid anymore. And so essentially participant A will have to drop out too, okay? Because their results are no longer valid, okay? So because these two people influence each other in a matched participants design, if one drops out, the other participant's results become futile or useless, essentially. Okay, so that's one of the issues with matched participants design, and that again contributes to the time-consuming nature of this design. Okay, so that's basically what a matched participants design looks like. So in terms of the research designs, are we kind of all good with them? Like we understand the main kind of feature of each one? And if you don't, let me know which one you want me to explain or clarify again. Okay, all good. Okay, so maybe I'll just continue. If you do come across any confusions, you can always ask me on chat or use the social stream later on. Cool. So just before we finish, I'm just gonna go through the types of studies that are used to gather information for psychological research. According to the VCA study design, we don't actually have to know everything. We just need to know a few specific types. Okay. Okay, so just a question, what's an example of an experiment that uses a matched participant design? Okay, so when we look at, if a case study is using a matched participants design, you might see something like, I don't know, a researcher was investigating the effect of, a researcher was investigating the effect of, alcohol consumption on driving ability. Okay, so obviously what we're trying to do now is we have to match participants in terms of two variables. We have to match participants in terms of their general alcohol tolerance level, and we have to match participants in terms of having similar number of years of driving ability and driving experience. So in the context of this example, if I'm going to talk about person A, and then match them to person, if I'm talking about person A and then person A's match, I want to make sure person A and person A's match both have a similar level of alcohol tolerance. What does alcohol tolerance mean? It means that some people get drunk and after having one beer, some people don't get drunk until having 3 or 4 beers, okay? We want to make sure that the alcohol tolerance level is similar in both participants in that matched pair. Also, we want to ensure that if person A has been driving for, let's say 50, sorry, not 50, that's too old, has been driving for like 15 years, we want to make sure that person A's match has also been driving for approximately 15 or so years, okay? And by making sure that we match both participants on that variable, we are ensuring that that is a good matched pair and that there will be less individual participant differences there. So again, a lot of the time in case studies, they will make some mention of, you know, ensuring that participants' IQ levels are as close as possible, or ensuring that driving abilities, that all participants had a similar level of driving ability. So they might use words like similar level, or similar ability, or similar similar skill set, etc. So there's some aspect there that gives you a hint that the researcher is trying to match the participants on a specific variable. Okay, we'll look at some of those examples next week as well. So, much time?
Yes.
Minutes. Yes.
If we're talking about the limitations for repeated measures, do we have to mention in counterbalancing? Like, do we have to introduce it?
No, you don't have to. You can just say that the main potential confounding variable is order effect. If the question asks you how can that potential confounding variable be minimized, then you would bring up the counterbalancing. But you don't have to mention counterbalancing every time you mention order effect.
It's not wrong to, right?
No, if you do it, it's not wrong. It's not wrong. But again, like if you're running out of time and stuff, it might like take you a few extra seconds to write that down. But yeah, if you
Right.
you won't lose marks. That's fine.
Yep.
Okay, so the next thing we're gonna just actually, you know what? Maybe I don't know if I should start this right now. Yeah, I'm not gonna start this because then I won't finish it all, and then I'll be annoyed that I started it halfway. Anyway, so what we'll do is we'll stop here. And basically what I want you guys to do today is, again, revise through what we've done so far and be really familiar. If you need to add extra information to your notes, add extra information to your notes, and basically finish off your learning activities for up to this content today. I'll post up the little snapshot of what you need to do, or which specific learning activities are due for these topics we covered today. But yeah, that's about it. So I'm not going to waste any more time. If you have any other questions, you can just ask me now. I will probably first stop the recording here.